Hey you guys, this is notes number 10, transformations, part 2. Go ahead and write down this FLT here. Okay, and press play whenever you're ready, okay? So, similar FLT to the last set of notes, we're still going to focus on linear, quadratic, and absolute functions, absolute value functions. You're going to be able to identify the effects of what we call A, okay, by describing, graphing, and or explicitly defining the function. Okay, so we have 3 parameters. You guys already went over h and k. Okay, what I want you to do, without looking at your notes, try not to, write down what the effects of h are. Okay, and then write down what the effects of k are. And then when you're done, you can press play. So basically, h and k will give you a translation, okay? But this right here is your horizontal movement or translation. You could use the word shift if you want as well. And k is your vertical translation, which is basically making the graph go up and down, okay? Now, remember, h and k are constants. They're both constants. So how do you separate the two? We're going to write down that, remember, h is inside the function, k is outside. So if you're ever confused on which one is h and which one is k, remember h is always inside of the function and k is always outside of the function, all right? Okay, so then there's one more parameter that you guys have to take care of, okay? And I'll use a parabola as an example, but it can be translated to any other function that you want. So this is what you guys are used to, x minus h quantity squared plus a k. But now there's this new parameter, a in the front, okay? Now notice how a is multiplying with that quantity. It's multiplying with the variable. So this a here, first off, we could tell the difference because a is right next to a variable. We call that a coefficient. So don't confuse an a with a h or a k, because remember, h and k are just constants, numbers that are by themselves, and a here is a coefficient because it's right next to the x. It's multiplying with the x there, all right? Now, what the heck does a do? That's what we're going to try to figure out today, okay? So we're going to go ahead and explore what happens when I put a number in front of the x, all right? So I'm going to use decimals here. You guys are more than welcome to use it too if you want to follow along. So we're going to stick with our parent function, y equals x squared right there. Let me put in the units so that you guys are seeing what I'm doing. Okay. So what I'm going to do is I'm going to write y equals, and I'm going to throw in a parameter a. X squared. It's in the front. Okay. I'm going to add the slider here. And I'm going to let this run first. Let me go from 0 to 10. And I'll slow it down a little bit, okay? So right now a is currently at 1. All right? I'll slow it down a lot. Take a look at what happens when the a value changes and what happens to the graph when you change the value of a. All right? Remember, red is the original graph. Right now a is at 2 and it's getting larger. A is just getting larger slowly. What is happening to that blue graph? Right? Some of you might say that it's getting thinner. The more proper term is it's getting narrow. The even more proper term is there is a vertical stretch. Imagine as if you were to hold down this blue parabola and it was like a rubber band. If you were to pull it vertically, you're stretching it and it gets narrow, it gets thin, right? And notice how when A gets larger and larger, it just gets more narrow and more narrow. Okay, there's more of a vertical stretch. Okay, now we can go all day, but I'm just going to go up to 10. Now, let me go ahead and go back to the value of 1, because that's where we start. That's where the parent function starts. Think about what would happen if A got smaller, right? So right now, let me do this again. Right now, A is approaching that 1 value, which will give us the parent function. Okay. Now take a look at what happens when A dips below 1. How would you describe that? Right? And it happens really quickly. So let me play that again. And you guys should play it a couple times. When it gets less than 1, notice how it gets a little bit wider, right? The proper term here is there's a vertical shrink. If you were to press down on it, if you were to squish it, it would get wider and wider and wider, okay? So, let's write that down. We notice that things change before and after the number 1, because the number 1 is where our parent function is, okay? So what happened when A was greater than 1, when A got really large? Go ahead and write down your thoughts there. Red in pencil, in case you need to erase it. Okay? And press play when you're ready. When A was larger than 1, okay, there was a vertical stretch. Vertical stretch, aka it's getting narrow. It's very easy to see how it's narrow with a parabola. With a line, it's a little bit tougher to see. Absolute values, you can see it as well. Okay. Now, what happened when A was a little bit less than 1, somewhere between 0 and 1? Okay. Go ahead and write that down. There was a vertical shrink. Okay, we were making things wider. Make sure that it makes logical sense to you guys, okay? When the A value was getting larger, there was a vertical stretch. You could obviously tell that it got narrow. And then when A was a little bit less than 1, notice how it got wider and wider and wider because you vertically shrunk it. Okay? Gets wider and wider and wider than the original one. But notice, here's my question to you guys. Regardless of what A is, did we pick up the entire graph and move it, just like how we did with H and K? Okay? Did that vertex move? Okay? The answer to that is no, there is no movement. So A does not contribute to a translation, meaning A does not make the graph move at all. All A does is, for now, we know that we could stretch it vertically or shrink it vertically, but we're not translating it. We're not moving it horizontally. We're not moving it vertically like H and K. All right? Notice how that vertex right there, that vertex doesn't go anywhere. It just stays at 0, 0. All right? But the rest of the graph gets stretched or it shrinks, but it doesn't translate. Okay? Okay, so here's the thing though. You know, with H and K, we figured out what happened when H was positive and when H was negative. Same thing with K. We try to figure out what happens when K was positive and when K was negative. But I didn't make A negative yet. Okay? So here's what you guys have to understand. A, the parameter A, actually does two things to our graph. So right now, we know that there's a stretch or a shrink. If you want to get fancy, the technical term is there's a dilation. Kind of like when you get your pupils dilated. It either stretches or it shrinks. Okay, so the general term to stretch or shrink is to dilate. All right, but A does something else to your graph as well. Okay, so let's take a look at what happens when I change A to go all the way to, I don't know, negative numbers. Let's see what happens here. So let me speed this up so that we're a little bit closer. So right now we're at 1. I want you guys to pay attention to see what happens when A goes negative. So right now A is 0, and then now A is negative. What just happened there? What do you notice? Right? So some of you might notice that it flipped upside down. But take a look. As we move towards negative 10, is it getting more narrow or is it getting more wide or wider? Right? Notice how it's still getting more narrow. Okay, but we notice that whenever A is negative, there's a flip, right? That fancy term right there is called a reflection across the x-axis. A reflection is like a mirror. When you look at a mirror, the exact same object reflects back at you, okay? So here we go. We're going to change this up a little bit. So when A is negative, okay, or when you could say when A is less than 0, because those are all the negative numbers, what happens, right? There is a reflection. I don't have space, but you guys should write it over here. Across the x-axis. There's a reflection across the x-axis. Okay? So, here's the thing though. One more thing to poke at. Let's say A was negative 6. Clearly there is a reflection because it's upside down now, right? Now, is that blue graph more narrow or more wide or wider than the red graph? Think about that. Press play when you're ready. This graph, although reflected, it's still more narrow than the red graph. Okay? So here's the thing. We go back and there's something a little bit off about this because we said that things are going to get narrow when A is bigger than 1, right? But take a look. We have a very narrow blue graph, but A is negative 6. Negative 6 is not it's not greater than 1. So there's something off about this, right? So here's what we do. The negative makes the graph reflect. Okay? Now, if we ignore the negative, that A value would be 6. And 6 is bigger than 1, which makes it narrow. So what symbol in math do we use so that we ignore the negative sign? Right? So what we do here is we ignore the negative sign by putting absolute value bars right there. That's basically saying ignore the sign, okay? Same thing here. Ignore the sign. If you just look at the digits, if it's greater than 1, you know there's going to be a vertical stretch. If it's less than 1, you know there's going to be a vertical shrink, okay? So, there you have it, okay? So let me give you an example. We'll do 1 or 2, and then that's it for the day, all right? Example 1. We're going to go ahead and try to describe and sketch the graph, okay? So let's say I gave you guys part A, y equals negative 3x squared. Okay? A good place to start is, well, do you know what kind of picture you have? Okay? what type of shape do we have here? So based on the degree, we could tell that we're going to have a parabola. Okay. Now, does this parabola translate anywhere? If you notice, there's no h and there's no k value here. So there is no translation. But I'll color code this. What does that negative do? Okay. Pause and press play when you're ready, okay? That negative tells me that there's going to be a reflection across the x-axis. So a parabola that has a reflection across the x-axis. Okay? Now, the last part, just that 3. What does that tell you when a is 3? Remember, we're not looking at the negative sign, we're just looking at the value, okay? Since a is 3 and 3 is greater than 1, that tells me there's a vertical stretch. What does the vertical stretch mean? We're just making it more narrow, okay? So we're going to say a parabola that has a reflection across the x-axis and a vertical stretch. Okay, that's it. All right, so here we go. Let's quickly sketch it. For reference, I always graph the original parent function. I'll use red just like we did in Desmos. So I'll call this our parent function, y equals x squared. Okay, so how do we graph this blue function here, right? So we said it was going to be a parabola that has a reflection across the x-axis, meaning that that U shape goes upside down. So it's like a upside down parabola, but also that it's going to have a vertical stretch. Remember, what does a vertical stretch mean? It just makes it more narrow. So you're going to draw a very narrow upside down parabola. So you got something that looks like this. You can even emphasize it if you want to. You can exaggerate, make it even more narrow. But notice how that vertex does not move because we did not translate the function. There was no h or k. And that's it. Okay, let's do one more, part B. Let's go ahead and describe and sketch y equals 0.2 x squared. Okay? Actually, you know what? Let's do 0.2 absolute value of x just so that you guys get a wide range of problems here, okay? Okay, so first place to start is what type of picture are you dealing with? We're dealing with the absolute value. So absolute value function. So we know it's going to be a V shape. Okay. Now, are there any reflections? Press play when you're ready. There are no reflections here because A is not negative. Okay, A is actually positive right here. So there's no reflections. Now, what does that 0.2 do? We now know that A is 0.2, which is definitely smaller than 1. What happens when A is less than 1? There is a vertical shrink, meaning you're making it wider. Okay? So, an absolute value function that has a vertical shrink because of that 0.2. All right, and that's it. We sketch it. Okay, the original function, the parent function here should be a absolute value V shape. That is our parent function. And then we're going to go ahead and sketch our blue function here. We know it's going to face upwards. It's not going to face downwards because there's no reflection. But we know we have to draw something a little bit wider because the vertical shrink makes things wider. So you exaggerate right there is your y equals 0.2 absolute value of x. And that's it. Okay? Here's my last example for you guys. All right? This is where I want you to be, okay, with practice, all right? How do we incorporate all of them? Okay? How do we incorporate all three? So, let's say I gave you y equals -3 times the quantity of x minus 4 squared plus 2. Okay? So at the very least here, and I'll do as many as we need to, you guys, all right? At the very least, you should know what type of picture you have in terms of the shape at the very least, okay? So we know, and you guys could actually try this out on your own, so feel free to pause if you need to. At the very least, I know that I'm dealing with a quadratic function, so that tells me that I have a parabola. Okay? Now, what does that negative do? Okay, that negative tells me what? Okay. And then that 3 tells me what? And then that 4 tells me what? And that plus 2, whoa, same idea. What do all of these parameters tell me? So I'm going to have you guys fill out the 4 lines here, okay? What are the 4 different types of transformations that you see here? Take your time. It's no rush. Go at your own pace here. Press play whenever you're ready. So that negative, okay, tells me that there's going to be a reflection across the x-axis. I should say that has. Okay, good. That 3, what does that tell you? There's going to be a vertical stretch. Since 3 is larger than 1, you know there's going to be a vertical stretch, meaning that it's going to get more narrow, okay? Or narrower, if that's a word. Okay? What does that do? Okay, that's your horizontal shift, but this is going to be 4 units. I should say translates 4 units to the right. If you got that, good job. Remember, H is a little bit backwards, okay? And the last one here, okay, plus 2, what does that do? That'll translate 2 units where? Well, since K is positive, we're going to go 2 units upward, or 2 units up. Okay? That's how you kind of wrap everything together, you guys. Let's go ahead and sketch this. Here's the thing. Order of operations. Okay? Order of operations tells us to multiply and divide first before we add and subtract. Okay? So the thing is, you have to go in a particular order. We have to talk about reflections and dilations first before we do any of the translations. We have to multiply before we add. That's the logic behind it, okay? So whether you reflect or stretch first, it does not matter, okay? But you cannot translate first and then reflect, because you will not get the same picture. So here's what we're going to do. We have our parent function, which I'll draw in red here. Okay, we know we're going to reflect it, and I'm going to draw using dotted lines because that'll tell me that this is not the final picture, okay? So I'm going to use the same color. So the reflection is going to be orange, So I'm going to reflect it. And I'll just label that this is my reflection. Okay. And from my reflection, now I don't start over, okay, you guys? From my reflection, there's going to be a vertical stretch. So I'm going to make this more narrow. I should have used a different color here. So from the orange one, I'm going to make it more narrow, or the vertical stretch. So now I'm paying attention to the dotted red line here, you guys, okay? From there, I'm going to move 4 units to the right. So let me set up 4 units to the right here. And then I'm going to go 2 units upwards. So here in in purple, I'll follow the same color. I'm going to take that red dotted graph and I'm going to move that to the right 4 units. So it'll land right there and you'll get something that's still narrow. Okay, so I'll just say that this is 4 units to the right. And then from that pink graph, I have to move it up 2 units. Okay, it looks crazy because everything is on the graph right now. So if I move that vertex up 2, I pretty much get this. And I'm going to draw this as a solid. Okay. Now, by all means, you could definitely jump straight to the answer if you know this very well. If you have trouble visualizing it, I encourage you to draw it out one at a time. So I'll call this y equals, since this is my final answer, I'll call this negative 3 x minus 4 squared plus 2. Okay, and that's it. All right, one for you guys to try and I'm all done. All right, here we go. Part B, last one for the day. Y equals negative 0.4, absolute value of x plus 3 minus 2. Pause there, go as far as you can. Remember, first describe it, and then second, graph it. And when you're all done, press play, and I'll reveal everything else, okay? All right, here we go. So we know that this is an absolute value function. Okay, that has, and then there's a lot that's going on here. Okay, it's not always going to be 4, but I'm just writing out 4 because I see it. That negative contributes to a reflection across the x-axis. Okay, the 0.4 contributes to a vertical what, you guys? 0.4 is a vertical shrink, meaning that it's getting wider, okay? Okay. Plus 3. H works weird, so that's 3 units to the right. Just kidding. I wanted to check to make sure you guys understand. It's to the left, all right? Remember, H is a little bit opposite. Some people see plus 3, think opposite, minus 3. So we go left, all right? And lastly, the minus 2, 2 units down. All right? So describing it is easy. How do we quickly sketch it, right? So here we go. We have an absolute value function. So I'll draw the parent function in red. That's the color that we've been using. Make sure that it looks like a V shape and not a parabola. This is our parent. Cool. There's a reflection. So I know it is going upside down here. So that is our reflection. Okay. I know that it has to shrink vertically, meaning it's going to get wider. So from my reflected piece, I'm going to draw something even wider than that green one. Okay, so there's your vertical shrink. Okay, then I take that orange graph and I will move it 3 units to the left. Okay. That's the horizontal shift. And then I move that 2 units up. Okay, so I'm going up 1, up 2. Notice how I'm just focusing on that vertex, okay? Because everything else will move along with it. And then since that's the final answer, I'm going to go ahead and bold it there. And bold it there. This right here will be y equals negative 0.4. Absolute value of x plus 3 minus 2. Obviously, if you color coordinate, this will be easy to understand. If you're just using a pencil, it may be a little bit tougher, okay? And draw it a little bit larger too, if that helps, all right? But that's basically it, okay? So recap, the effects of H and K, that's your translation, horizontal translation or vertical translation. A has 2 jobs. It can dilate your graph, but it can also reflect your graph, okay? When A is larger than 1, there's a stretch. When it's less than 1, there's a shrink. And when A is negative, there is a reflection across the x-axis, okay? That's it. Practice as much as you guys can. This is where we kind of graduate with graphing, okay? Instead of making a giant table, we just have a general idea of what things look like, okay? Let me know if you guys have any questions, and go ahead and get started on your homework, okay?